plan first here. Okay, so this is week 5. As you can see, there are 2 chapters we can cover. So today we're going to cover this chapter 7, basic routing concept and EIGRP, right? Okay, so this is quite a big chapter, but most of it is about the routers, yeah. And tomorrow we're going to look at chapter 8, which is LAN security concepts. Okay, right. So if we don't manage to finish chapter 7, we'll do half tomorrow, half, and then continue with chapter 8. Yeah, chapter 8 usually is a shorter chapter than chapter 7 in terms of content. All right. So we've done tutorial 6 already. So we'll start with depending on how far we've gone towards this chapter 7. We'll do the questions, yeah, for tutorial 7 later, basic routing concept as well, and EIGRP. Okay, and this week's practical related to that will be configuring basic EIGRP for IP version 4, yeah, right? Okay, and mostly there are a couple of labs for self-review, and then end up with the chapter 8 practical, which is switch security configuration. Okay, so let me share our slides today. We'll start recording as well, yeah. Okay, so it's chapter 7. Equivalent module on Ergrp will be module 14, routing concepts, yeah. All right, so let's look at the objectives for this part of chapter 7. Right, so there's quite a few there. Right, we're going to look at path determination. Right, and this section explained to us how routers determine the best path. Okay, we already know that routers forwards packets, right, between networks. Okay, so first topic, path determination, and then after that we're going to look at the router forwarding the packets themselves, right? How do they do that? And after that we'll look at configuring basic router. Okay, we've done this before, so just a review, yeah. Reviewing back what are the basic router configuration that you need to do. And then we're going to look at our IP routing table. This routing table can be found within the router itself, right? So to understand the routing, okay, we have to know what are the information available on the routing table so that we know what is the process that the router goes through in order to forward packets, right, between networks. Okay, and then finally we look at 2 ways of configuring the routing table. First one is static. Static means the administrator will basically go into the router and configure it, yeah. And the second one is dynamic routing, means using protocol. Later we'll look at EIGRP, and this involves dynamically creating the routing table with information, especially from remote networks. Okay, so the router will know all the networks connected directly to it. Okay, directly connected networks means the networks connect to the router via interfaces. Okay, so each of the interfaces on the router is basically a network, right? We call those directly connected networks. Dynamic routing allows the router to also get information from remote networks, meaning one or two or more hops away from networks that's not directly connected to the router that is under consideration. So that means that router will need other routers to inform it, right, about other remote networks, okay, so that the router is able to do the path determination and after that to forward the packets. Okay, right. So let's look at the first topic, which is path determination first. Right. So let's recall back functions of a router. In general, we say that the router forwards packets, right? And usually the router uses a routing table. Okay, on the routing table, there's information where networks are mapped to interfaces of the router. Now, this is true for, as I mentioned before, directly connected networks. Okay, and the router also needs to know, okay, about remote networks. Okay, so either this is specified by the administrator. Okay, we call them static routing table. But a lot of times it's very inconvenient, right? So we use certain protocols to allow the routers, okay, to form a group and talk to each other. So routers within the group, okay, will be exchanging routing table information, all right? And usually it consists of remote networks, okay? So functions of a router. When a router receives an IP packet from one interface, means ingress, yeah, right? Now it needs to know what to do with that packet. Basically, it needs to route that packet. So it needs to find out which of the other interfaces, okay, that it should forward that received packet towards, right? And the hope that the packets will, after being forwarded via the other identified interface, the packets can be forwarded further, okay, onto destination. And this is what we call routing. Routing simply means finding which interface, okay, getting one packet, a packet from one interface and deciding which other interface to forward the packet. Okay, so this is called routing. Okay, so there are two scenarios. The interface that the router decide to forward the packets to can be the final destination, meaning the destination is directly connected network. Okay, or it might not be the final destination, so it needs to be routed another hop. Okay, so in that case means the packets needs to arrive. The destination is a remote network further along the network, right? Okay. Right, so primary functions of the router is to determine the best path, right? And sometimes if the interface are limited, okay, the best path is normally also the single path. But there are situations where you may have more than one interface, so you have to decide. And equally, sometimes the many interfaces is available for you as a router to forward, and you can still reach destination. So then you fall back to deciding. Router have to decide amongst the available interface which one is the best interface. I mean, leads to the best path to forward the packets, right? So a lot of the decision making is actually based on analyzing its internal routing table. Okay, finding the match, right? Finding the match between the network and the interfaces. The mapping is there, right? This is very similar in concept with switch. Switch, we map MAC address with the port, right? The switch port. Here, for router, we match the network address, okay, with the interface on the router. Okay, we already learned previously in a previous course, the introductory course, how the router extract the network address from the destination IP address is by performing in binary, okay, the AND operation, AND logical operation. Okay, you apply AND operation using subnet mask in binary. You AND it with the destination IP address. The router will be able to get the network address. So we're not going to cover that anymore. We assume that you'll still remember how to do the ANDing, right? All right. So here's a diagram of what we are discussing earlier. So the main point is here. The router use the routing table, okay, and to find the mapping, right? So let's say the router already extracted the network address from the destination IP address. So the router will look at the network address and try to find a match in its routing table. If it finds a match, right, then it will look at the equivalent interface that network address is mapped to. That means if it's connected lah. So again, two possibilities, right? Directly connected networks means destination is attached to the network via the interface already. If it's not, then it's probably a remote network. So still need to know which interface, right, should the router use in order for the packet to be forwarded to the remote network. Okay, and now that is where the router needs additional information that it gets from remote or the next hop. Okay, the next hop or the next router. Okay, because it has no idea about remote networks, right? So the only way to get the info is from the neighboring routers. Okay. All right, so what happens if there's no match and there's no remote networks information? Then it will fall down to, later we'll see this again, to the default route. Okay, default route simply is administratively entered into the as a catch-all, right? Now, what happens if the administrator did not set the default route? Okay, if there's no match default route, if there's no default route, what happened? Okay, so simply the packet will be dropped. Okay, it will be dropped. We'll revisit this later. Yeah. So you can see here, this LAN where the packet originates from is 192.168.1.0/24. Okay, this is the network address for this LAN, and it needs to send it to a remote because it is one hop, minimum at one hop away. Directly connected network. Remember, if this is the router in under consideration with exclamation mark here, directly connected network means directly connected to its interface. So directly connected network to this router, if we consider the origin 192.168.1.0, is this 192.168.2.0, right? And this router should have no information about this because it's not directly connected to it. So router 2 is the neighboring router that's going to provide the information of its directly connected network to R1. And if they're part of the same group, right, router 2 will send that via a protocol, right? And we will talk about available protocols later. R1 will do the same because for R2 point of view, R2 directly connected network is this and this, and have no idea about this one, right? So R1 will then share that information of its directly connected network with R2. So they are both work together to build a more complete picture of the routing table, right? So let's say this router now needs to send to this address. Okay, so when it checks the map, right? This is a table, the representation for viewing. You can view the routing table by typing this command, show IP route. Okay, show IP route. And here are the legends, right? To be able to understand what are the codes being used. So C means connected, it's directly connected, right? And S static. S static means it's not learned from any protocol. Okay, static means you as the administrator, right? Directly type in this information in. You are the one set this as a static route. Okay, this is usually the case when it's not very complex lah. That means you basically have one ingress, one egress, right? Okay, so it's more useful when you're using dynamic updates of the routing table when you have a more complex network, where it's tedious for you as administrator to go and keep updating all the networks. All the routers available in the network, right? Remember, also, it's useful when you're at the edge of your network. Meaning to say, if you have control over the router that's working right here, then you can access them, right? But if you're at the edge, maybe the next hop router is not administratively available to you. Some other organization is handling that router. So in order for you to, that means you will not know what is the information, right? A lot of the information. So in that case, probably it's also useful to use protocol. But of course, the two organizations, usually it's not organization to organization. Usually it's organization to the service provider, right? So that means a service provider will provide that information for you. Right. So since the first directly connected, the ingress is this one, so we're not gonna the router is not gonna check the ingress again because you're not gonna send it back, right? So the next available to match is .2, right? But the network address is .3, right? If you, I'm just giving an example. Let's say your packet is supposed to destination is supposed to be .3, yeah. Okay, so this will not match. But then it goes further, and then because this is statically put in as by the administrator already know that the remote network is this. So if you want to send to or forward to this remote network, what do you do? There's only, here is very simple. There's only one interface that is leading to this network address. This if you send through here, through this network, means it can find a route, okay, to eventually reach destination, which is .3. So you can see here as an example, 192.168.3 match via 192.168.2. So you know that this is via this. So you find what is this one. You find again the routing table, which you find 192.168.2.0. Yes, it match this one, match this one. The first match is this, to match via this, right? And then you take this, the router takes this and try to match again. Yes, it finds this one, right? And it finds out that finally the interface serial 0 is the interface to send through. So the packet will be just forwarded via this interface. Okay. Okay, this is a simple situation scenario, but you can see how it works. Not matching this one because it's ingress. Doesn't match this one. Match this one. You follow, the router will follow through. All right, so it should go to this network address. So okay, follow through again. No, sorry, this one is the destination IP address for this. So if you extract the network address from this, you can match this one, which is matched serial port, which is here, right? So that is the interface you're gonna the router is gonna forward, right? So this is a very simple situation, just to give you an idea how the routing table looks like if you type show IP route and how it's used by the router. Okay. So far, okay, everyone?
Yeah.
Yeah.
Yes.
Okay.
All right. Okay. So let's look at it more in more um, lower lower aspect. That means low level aspect means here is decimal, right? But to be honest, like just any other computers, right? Our router has got a chip inside, a processor, and you know all our digital uh, devices, including computers, switches, all of them using representation of information in binary, right? So let's look at that level, right? And this slide is about that. Okay, it says base path equals longest match. We know best path means the best path to forward the packet. What is longest match? Longest match simply means when we are uh, imagine that the router is going to perform the matching here, the network address part of the routing table. Of course, for us human, we are able to just simply look at the address, right? But we also know that internally inside the router, all these are in binary. Okay, so longest match means comparison for each bit starting from the left handmost of the address. We also know already, from our previous introduction knowledge, that when we have the IP address, it's actually a hierarchical, right? Addressing, whereby you have one part network address, the other part host address, right? And because router is basically dealing with network address, right? So the router will be interested on the leftmost part of the IP address, which is the network address part. So when it's going to match those bits, those network address bits. And how does the router knows how many bits belong to network part? Again, we have already learned about this. Okay, this one prefix length, right? The slash number, decimal number, right? And that decimal number converted to binary is means we can actually say how many bits belong to the network portion. All right, and that is the network portion bits are the one that's going to be compare, right? Compare between the network that it's the router already extract using the AND logical AND with the network address that is stored inside the routing table, right? So you can see here, right? Routing table contains route entries consisting of prefix, network address, and prefix length. The prefix length just tell us the network address part is how many bits, right? So that means there's if you say that, okay, we want to find a match, right? So what does it mean? It means to be a match between the destination IP and a route, okay, a route in the routing table, a minimum number of far left, see, far left bits. Okay, you start looking at the bits in the IP address from the far left because concerned only with the network address part compared to the host. We don't want for router don't look at the host. Okay, the host, right? The host is a way to differentiate between the destination host, right? But in order for the router to do its work of routing, it only looks at the network address, right? So it says here to match means to match a minimum number of far left bits. Okay, right. So the prefix length is telling the router the slash something slash number, right? Of course, in binary, right? The prefix length of the route in the routing table is used to determine the minimum number of far left bits that must match. So if it's /8, then must match the 8 bits. Okay, right? So the longest match is the route in the routing table that has the greatest number of far left matching bits with the destination IP address of the packet, right? And then from the router point of view, the longest match is always the preferred route. Okay, the longest matches means how many bits from the left it match. The longer, that means the more bits you match, the longer is the match. So the preferred one is the one that matches the most bits, which means the longest match. Is that okay so far?
Okay.
Okay.
Yeah. Longest match, because the most number of bits match means it will be the longest match lah, right? The least amount of bits match means it's the shorter, right? So longest means is among all the candidate is the longest match. All the candidate means candidate entries inside the routing table. All right, so let's just have a look at the example here, right? So IP version 4 packet has the destination IP version 4 address of this one, right? 172.16.10.0.10, right? So of course, this one, right, is the .10 means it's a host, but we extract the network address, and the router has 3 routing entries in its IP version 4 routing table, right? So you can see there, and sometimes it's difficult because you see 17. If you just look at without the prefix, without the prefix length, you know, it's quite difficult to decide because they all seem to match. 172.16.0.0, 172.16, right? Okay. Sometimes because of the way we segment networks, right? The original network address seems to be the same until we consider prefix length. Right? Prefix length tells us exactly how many bits belong to network portion, right? So that's why this prefix length is very, very important, okay, to differentiate. So you can see without the prefix length, very difficult for us to differentiate. It means we cannot differentiate basically. So with the prefix length, oh, we know already this one /12/18. So we have to consider 12 bits. Here, 18 bits. Here, 26 bits. Right? Okay. So of the 3 routes, okay, the first one has the the third one /26 has the longest match and will be chosen to forward the packet. For any of these routes to be considered a match, there must be at least the number of matching bits indicated by the subnet mask of the route. Right? Okay. So have a look at this. This one match, but only up to here, because 12. Here match only up to here, 18. This one match all the way to 26. Okay, with the original entry, with the original destination IP version 4 address. Right. So this will win, right? This this considered as the longest match. This one is the preferred one to match. So that's simply what it means, right? You can see, you count the number of bits. This one has the longest match. This one shortest match. This one midpoint match, right? Among the 3 candidates to match. Okay, all right. So let's move on to the next one, path determination. Okay, building the routing table. Okay, directly. So here is where we've been discussing earlier on: directly connected networks, remote networks, and default route. And how are these 3? Okay, we already discussed what they are, right? Directly connected networks are directly connected to that router under consideration. And then remote networks are unknown networks to the router, but is informed, right? Either informed by other routers, okay, neighboring routers, or specified by the administrator. If the administrator have access to the other router or the other networks, it knows, that means the administrator know the addressing, right? And it's a simpler network, then maybe the administrator may decide to do the entry themselves, or himself or herself, right? But if it's not, then maybe a bit more complex, or you don't have precise information. You rather need the the routers tell each other what their directly connected networks are, okay, to each other, so that it's updated, right? So it's dynamic, right? And then default route is if all else doesn't match, all else failed, and trying to match cannot match any, then this is the default route, sometimes known as gateway of last resort. Last resort means after everything the router did to match cannot match. Okay, there's one last option, which is send it to the gateway of last resort, means to the default route. And this is specified by the administrator, or learn automatically from other routers. Right? So if this fails, means there's no default route, the packet is dropped. Okay? So directly connected networks is added to the routing table when you configure the local interface, the interface belonging to the router, right? Because you configure the interface with an IP address and subnet mask, correct? You have to put subnet mask as well, so that you can differentiate between similar network address. Okay, sometimes the similar network address has only the subnet mask to differentiate, as I mentioned earlier on the slide before, right? If it's in the shutdown mode, then it will not, the router will not consider it to add into routing table yet. But if you set the interface IP address and its subnet mask, and then you no shutdown, yeah, you bring it up, the router will then add that particular network address of that particular IP address into its routing table. Okay. Next, remote networks, not directly connected. So routers may learn about remote networks in two ways. Static routes, this is manually configured. Administrator put in. Administrator know what are the remote node networks addresses, so they configure, right? Or automatically or dynamically, right? That means other routers will share, right? Share their directly connected networks to other routers. So other routers, of course, those networks they learn about are not directly connected to them. That's why they need the information from other routers. But in the perspective of the other routers, those remote networks actually, to them, it's directly connected, right? So each router knows its own directly connected networks, okay, which is remote networks to other routers. So by sharing, using a protocol, by sharing the routing table information, they all will have a more complete, okay, routing table to allow them to decide, okay, to determine the best path to route. Right. So the third one is default route. Default route are usually configured in this manner. This one could be S0000 or S, whichever interface you as the administrator determines as the default route. Okay, so this one can change, but usually default route is set to 0000, means it will match anything. If it doesn't match whatever inside the routing table, and this is like the switch case, when your default, right, default part of your switch case, remember in programming, right? So just trying to relate it with some other knowledge that you already have. So this, consider this as the default, right? If nothing match, then if you have this configured, then this will match definitely. It's a catch-all, right? So you can see that here, default route has a /0 prefix length, means no need to match any bits at all. It will match. But this is not the first thing that the router will consider, right? The router will consider its routing table first. Only when the routing table, result no match, then if this configured, the router will consider to match against this, right? And since there's no matching, /0 means it will match anything anyway. So that's why it's been said as a default route, okay? Or gateway of last resort. Okay, you guys so far okay? Any question?
Okay.
No.
Okay.
Okay.
All right. Let's look at routing decision. So router is actually very logical, and see here we see a flow chart. A flow chart is a systematic way for considering the logic, okay, of decision making. Very similar to your flow chart for your program. Your program will follow, right, depending on and when your program have to make a decision, right, then result of the decision allows it to proceed. Similar with the router, right? When you see the diamond shape, it's like in the flow chart, is a decision that the router will have to do, and the result from that decision is will allow the router to find out what's next to do. Okay, so it's basically a series of if then else. Okay, logic. Right. So we follow it. It says let's look at this first. The kind of state or process that happens. Packet arrive on an interface. Router search the routing table for a match. Does the destination IP address match the subnet of A? First, it checks. Okay, router checks directly connected interface. If yes, right, do this part. Right, check Ergrp cache if necessary and forward to host on local subnet. It means because it's locally or directly connected network, definitely it will be forwarded to a switch. And the switch usually work with instead of packet, it will work with frame. So that's why we're talking about Ergrp cache here. Right, directly connected interface? No, it doesn't match any of the directly connected interface. That means it's remote, right? So we check remote next. If it match any remote networks that's available in the routing table, then encapsulate the frame and forward out the exit interface to the next hop, because, well, we know which interface goes to which. We forward through that interface and we let the packet be handled by the next hop, the next router. Okay, but if it doesn't match any of the remote networks, then we check the gateway of last resort, the default route. Is there a gateway of last resort available? If yes, encapsulate the frame and forward it out of that interface, the gateway of last resort interface. And if there is none configured by the administrator, or there is no gateway of last resort or default route, then it will fall to here, which means drop the packet. Nothing else can be done by the router, so it will drop the packet, which simply means that the packet cannot be forwarded. All right. Okay. Right. So if you guys have any questions, just let me know. Yeah. Right. So this is what we discussed. The explanation of this flow chart. So I think this flow chart is straightforward, right? Quite easy to read through, huh?
Yeah.
Because it's very simple, actually, the flow chart. So very straightforward, very clear.
So usually, the router have a default gateway. I mean, the result.
Yeah.
Default result.
Yeah. If you're the administrator, usually you won't provide that, right? Because
okay.
Usually the network administrator, they design the network. They know what are the networks belong under your administration. So you basically configure that router. Okay, if you configure the router, you already know, right, what network directly connected to the router. If the next hop is also belong to you under your administration, so you also know the next hop, what are the networks connected to it, right? It is when you are at the edge of your network, meaning the next hop is not belong to you anymore. And somehow those networks are hidden from you because, well, you're not administrating it. It belongs to another organization, usually the service provider, right? So unless the service provider or the person in charge of that network tell you information, you basically, if they tell you, okay, this is information, then you can configure that into your edge router. Okay, but if there's none, how do you know whether there's a gateway of last resort will definitely forward it to there, right? Okay, in that case, and also remote networks information, you won't know. So if they don't give you information, they normally will tell you to agree on a protocol for your router to be able to talk to their router. Not necessarily at the edge, right? For the dynamic part. Dynamic, you can also, depending on the complexity of your own network, and maybe you want to automate the maintenance of the routing table, then you may also within your own topology, you want to say, oh, I want them to self-learn these routers. But also, of course, you can do that at the edge, depending what is your agreement between your organization with the other organization in terms of capability to forward packets. Okay, is that okay, Noel?
Okay.
Yeah, right. So we proceed. Yeah. I think this was the initial example before. So just consider that R1, there are two routers, R1, R2. Okay, so consider if you're the administrator, you're configuring R1, configuring R2. If both this topology belongs to you, so you are the one who specify, you are the one who's going to design this network, so you are the one who's going to provide the network addresses, right? We've done this in a previous course, right? So you say, oh, this network address belongs to this network, and this network address belongs to this network, and for this network, you give this. So when you are configuring this, right, you will set interface IP address there, interface IP address there. This interface IP address will be the gateway for these hosts, correct? And this should be part of this network. This IP address should be part of this network. This IP address should be part of this network, correct? So for R1, this interface and this interface are directly connected network, which the moment you set these two interface, the router will update routing table under directly connected, right? So because you are the administrator, you also configure this and this and this, right? So okay, anything matching this one should be forwarded through this interface. Okay, so you can statically put that into the routing table. And safe to say that your default route also will be this, right? Your default route should also be this. Okay, basically you're handing out the forwarding decision towards R2 if you're using default route. Okay, so of course, if you know your topology, you don't even have to do the default route because you know if you forward it here, right? Let's say it's not this one, it matched something else, it reach here, there is no default route for that, right? Because here doesn't match, there's no more hop, it will be dropped here, right? So which one is more, let's say if you are the administrator, which one is more efficient? If you only have this kind of network, the most efficient is there is no, apart from this remote network, there is no other remote networks. So basically, there's no point to put default route because even if you allow the next route hop to process that packet, it doesn't go anywhere, right? Imagine that, okay, right? Sometimes, depending on the question, maybe they ask you because they just want to test you, set the default route. But in real life, I don't think if you are the, because by basically asking the R2, you set default route because it doesn't match this, doesn't match this, you know this is the end of the road. In order to reduce the processing for R2, why don't you just decide here, drop it. There's no default route basically, right? So usually if we have a more complex network where, yes, if you forward to R2, they have another path or multiple other path, right? Another hop connected, then maybe, yes, let the next router make the decision. That means you set the default route. You guys know what I'm talking about?
If remove the last result to reduce the what performance
in this topology, in this situation, right? There's no point to forward because even if you default route, it goes here because it doesn't match. Since you already put in this one remote information here, right? So if it doesn't match the remote, meaning it will drop down to default route, right? But where else your default route is going to forward only this? So you're going to forward it to R2. But when you reach R2, there's no other forwarding option, only this. Of course, this will not match. In the first place, it didn't match here. That's why it dropped to default route. When you forward here, there's no match again. So now you duplicate processing already for nothing because there's no way the R2 is going to forward it to anywhere. Since this one is not matched here, then it drops to default route. Default route you forward here because the only interface is this, right? So even if you know, and you cannot forward it back through the ingress port, always the forwarding, right? Not returning. So it's going to be dropped here anyway. That's what I'm saying.
So it's better to drop it on R1.
Yeah, that's why. So all this decision is actually up to you. You are the network administrator. How you want to configure your router to be as efficient as possible. Of course, if router 2 got a further hop, and this further hop have access to, as the edge of your network can forward to another hop which is not belong to you, then maybe you can forward the decision, right? Decision to check for that particular not match IP address. Yeah. Right. So okay. So we understand this topology. Anybody don't understand? You understand, right? Network.
Yeah.
Right.
Yeah.
Okay. R1 directly connected is this and this, right? R2 directly connected to R2 is this and this, the interface on R2. So R1's remote will be this one, R2 remote will be this one. Understood that part, yeah? Anything that's beyond one hop from that router in consideration will be remote. So this network is after this hop. So from R2 point of view, this is remote. From R1 point of view, which address is the network address is the remote? After the one hop, right? After the one hop, just like a jumping, right? So usually I imagine it like this. one hop and then reach. Okay. All right. Okay. All right. So for R1, this is the remote network. Okay. So when we understand the topology, we'll try to match it with the routing table. So for R1, look at that. We are inside R1. So when we look at the show IP route routing table, then we see the routing table for R1. So R1, what are the two directly connected network? This network and this network, right? Correct? For
Yeah.
R1, yeah. So we see C is connected or directly connected, right? So we see dot 1 and dot 2. This one and this one. What about this one? Dot 3. This is remote to R1, correct?
Yeah.
Yeah, so it's not automatically detected by the router. So it's not C. Okay. Now there are two possible ways for R1 to know about the remote network. One, R2 tells R1 because R2 knows about this because it's directly connected to R2. So R2 can share its information, its routing table with R1. And that's what we call dynamic routing. Okay. The other way for R1 to find out about this remote network is if the administrator key in, update the R1 routing table by the administrator himself or herself, do it. Okay. So this is what we call static. Static, yeah. Static because it's not changing until the administrator go and change it because it is the administrator that entered this info in the first place. Only possible if the administrator have access to this topology, this side of the topology, thereby knowing what are the address. Okay, because consider this. Okay, your network topology might connect to other network topology not belong to your organization. So the router that leads to the other network not belonging to your organization means the router is an edge router. Okay, so for edge router and for other routers under your administration, you will then find it very hard to do static because to do static, you need to know the topology addresses of the other organization's network. And sometimes they're very secretive, right? So you have to depend on your counterpart, right? That organization, whether they want to share the addresses with you. Then you can do the configuration yourself. Okay? But sometimes, and not limited to that only, right? You also can do it inside your own network. Sometimes you have an agreement with the organization. Okay, let's use this protocol so that our routers can update each other. Because if you want to forward to there, the return reply will also need to forward back to you, and you have to forward their packets. Correct? It's not just one-way street, it's two-way street. Okay? Meaning if they allow your packets to go inside their network, you also must accept the return packets. That's how network works. Right? So here, under S, which is static, means configured directly by the administrator, we see the entry for this remote network to R1, 192.168.3.0, right? And the path to go there, to forward to there is via this network, 192.168.2.2, right? Which is this interface, either this interface or this interface, usually this interface. So this maybe is 1 and this is 2, okay? Well, we don't know yet because not input here, but it doesn't matter. We know that it has to go through this this network. Okay, through this network, and it should match. Okay, because let's say the interface that you going to forward to, maybe this one, maybe this, I'm not sure. I have to check later. We check later, yeah. Anyway, the router can extract the network address from there and can match with serial 000, which is this interface, right? So which interface is it going to be forwarded to? So of course, if it goes through this interface, it end up here, and it's going to match R2's C, yeah, directly connected, okay, and will be here fast Ethernet. I'm not sure what is the port here lah, but fast Ethernet port. Okay, get forwarded to whichever the host here lah. Okay. No, okay, so here the example is source IP is under this address is 101. Destination is .22. We still don't know which one of these hosts is 22, right? But usually in the packet header, you have source, destination. Destination extract becomes 3.0, right? 3.0 because look at that, is /24. So /24 network address of this to extract using ending, you'll get 192.168.3.0, and it's going to match here as mentioned before, right? You can see there, not going to match there, right? Now, notice also that as this administrator have not set the gateway of last resort. So if there's no match, there's no gateway of last resort. Okay, which is actually what we expect because there are no other networks connected. This is isolated network. Right, apart from these networks, we don't see any other network we can forward. So if it doesn't match any here, then definitely there is no way for the gateway of last resort also to forward to. Right, no point lah, right? Okay. So again, working out how the matching, you follow the packet forwarding decision process. Very simple process, right? Okay. So if you follow, it's indicated here. Destination IP, is it directly connected interface? It's not C, right? The C doesn't match. So this will trigger no. Then the next option, right? You can see, right? But if it doesn't match, then it will go there lah. But because we can see that it doesn't match the C, right? Remote network, it match, right? And then from there you can the router can match that one, and it can match which interface lah. So this one will this process will execute, right? This process here, encapsulate the frame, forward out and exit interface to the next hop. Exit interface for this one, right? Right. This is a different scenario. Let's just check. I think it's the same, right? Yeah, I think it's the same. 1, 2, 3. Yeah. Wait, yes, it's the same. Oh, this is R2. Okay, R2. So for R2, this is directly connected. So we'll see 2 and 3. So remote to R2 is 1. You can see there. Okay. So imagine this is 1, this dot 1, dot 2 lah here. As you can see, BR 192.168. Right, so it's just here. Source IP is from there to go to there. Oh, okay, this continuation, right? Continuation with R2. Okay, just now we consider what happened forwarding decision for R1. Now we proceed because the packet has been forwarded to R2. So R2 also have to make the decision, forwarding decision, right? So since that is 3.0, 3.0 will match this one. Okay, remember this is R2. So the interface that's connected to the switch on R2 is this one, fast Ethernet 0. Right? Directly connected, yes. Then this process execute. Right? Right. So 1, 2, directly connected 1 and 2. This one is R1 again, show RP route. Yeah, okay. Then what happened if we are sending nowhere 5. Okay. We straight away know, because we are administrator, we know, oh, there is no 5. It definitely cannot be routed. But let's see what happens with the router. The router doesn't know until the router actually perform the flowchart. All right, packet arrive, router search. Is it directly connected? No, this is 1 and 2. This is 5, right? Okay. So no match. So no match, yeah. Is it remote network? Again, this is 3, this is 5. So no match. No match, huh? Right? And this one, gateway of last resort is not set. After we check directly connected, we check remote, we have to check gateway of last resort. Since it's not set, is there a gateway of last resort available? It's not set. Okay? It's not set. So this no will trigger. So what happened? Drop the packet. Yeah, drop the packet, and that means it cannot be forwarded. The router cannot forward it because that's the way it was configured. Right? In this case, all the logic from the flow chart is followed, but you as the administrator has set, right? Set, especially with this static route. And you decided not to put last resort. Okay, that means only the network available in your topology is considered by the router, right? All other network, definitely there's no way for the packet to be forwarded to. So that means most of the time, if you try to send to other destination, network address destination, you'll always be dropped by the router. Okay, but here what we want to highlight is the three ways the router goes through, okay, in order to perform the routing decision. Checking directly connected interface, checking whether there's any match in the remote network, and checking finally if there's no match on the two above, checking for gateway of last resort. Right? Right. So any questions so far? This one okay with you guys?
Okay.
Okay, Noah, Farah? So far following,
yeah.
Huh? Yeah. Kelvin?
Yeah.
Yeah. Okay. All right. So you have an idea already what the router is doing, yeah, in forwarding. All right. So just now was availability of destination for the router to select to forward. And it's straightforward lah. Basically the example. But sometimes you're more complex topology. So between we have and we know the network or the internet network is basically a mesh or partial mesh network, meaning it connect here, connect, right? So there will be more than one path, right? Okay, more than one path for your packets to travel through. Okay, so in that case, the decision of the router, okay, to forward is a little bit more complex also, right? Because not so straightforward. Now, what happens if there are multiple paths that the router can choose to forward, right? So, of course, we want the router to choose the best path. But what do we mean by the best path, right? So, again, there are different ways to decide what is the best path based on different attributes or whatever we want to define as the best path. Okay, because maybe Noel and Pera and Kelvin, maybe you guys, when face to face, you guys have to drive to campus already. So depending on your own preference, what will be the best road to take? Maybe Noel say, oh, with the less jam, right? Pharaoh maybe shortest path. I don't mind jam, but I don't want to drive too long. Noel don't like jam, so Noel say long path also good without jam. Maybe Kelvin say combination, right? Combination for Kelvin. I want the less jam and also the shortest path. Okay, so different criteria depending, right? Okay, so the best path also you have to define. Okay, and since there are maybe different needs, then how we define the best path, okay, and then we set for that router to follow that. Okay, so you can see here examples lah. So PC1 to PC2, we got 3 routers. They are connected. Okay, just remember, although we have potential to have a loop here, right? But it doesn't happen in a layer 3. In the router, it doesn't happen. But switch, yes, because layer 3, remember again, got the time to leave field. Okay, if the packet start to be passed around like this, every hop, the value of the TTL field will drop by 1, decrement by 1. When it reaches 0, it will be dropped. Okay, so it's a mechanism at layer 3 to prevent looping forever for the packets. So it's okay having this kind of configuration. In fact, this configuration actually is good, right? Because it provides redundancy and also different path if there's traffic jam. Okay, traffic jam in terms of congestion for the path, right? Okay, so we got alternate path lah. Right, so as you can see, depending on your definition for best path is what you want, right? Again, I repeat, Noel prefer no jams, right? Noel, no traffic jam because it gives you headache. So you don't mind taking the longer road. But Farah don't like to drive so far, to drive through those very long, maybe feel sleepy. So a little bit of jam, he said, don't mind, right? So the same here. You can see R1 to R2 to R3 is a T1 link. Now, if you recall your first course on network, T1 link is very fast, right? Faster than 56 kbps, kilobits per second. So this is slow. This is fast. But this is a long way around. Long way around. Have to go through another hop. Okay? Right? And of course, this hop also may have latency, right? But if we depend on best path being the least amount of hop means a router in between. One hop means there's one router in between. 2 hops mean there are two routers. So based on hop count, the best path, the lowest hop count. So lowest hop count is this one, right? So we say our metric, that we based on the metric. Okay, So you can see here the best path is selected based on the metric or value that is used by the routing protocol. So if the metric is hop count, this wins. So the router, when evaluating whether sent through this interface or through this interface, will decide this one based on hop count, isn't it? Okay. Or based on bandwidth. If you based on bandwidth, then instead of this one probably will win. Well, it's the faster bandwidth. Okay, again, then it depends. So okay, so metric, this is the generic keyword that we use as a measure. Metric means it can be depending what you consider is your metric. The metric can be hop count, can be bandwidth, can be something else, right? So in general, we say metric lah. Then it depends on what protocol we use. That protocol use what metric. That if you implement that protocol, then your router consider that metric that is used by that particular protocol. Example. So here we see we have three. Okay, the first protocol is called Routing Information Protocol, or RIP. The second one is Open Shortest Path First, or Ospf. And the third one, we're going to look deeper later. It's called Enhanced Interior Gateway Routing Protocol. A bit long-winded, right? But as computer science, people always like to have acronym names like this. In any way, RIP use hop count as the metric to decide. The router will look at hop count for this path. But for Ospf, the router will look at cumulative bandwidth from source to destination. From source to destination. If you specify that the router is using EIGRP, then the consideration is bandwidth, delay, load, reliability. Okay, meaning to say it has multiple levels, right? Instead of just simply say, oh, hop count, bandwidth first. Kalau sama bandwidth, then delay, then the load, then reliability, for example, for EIGRP. Okay. So far, okay, guys?
Yes.
Okay.
All right.
So you would rather jump through the slow route instead of jumping through two very fast routes?
Yeah, it depends. If you're using RIP based on hop count, then this one will win. There's only one hop. Here it will be two hop, two hops. So this one wins. In terms
of it depends on different protocol.
Yeah, yes, correct. Depending, that's why I said just now. I give example. Noel probably like no traffic jam. Fairer decide shorter path, right? So it depends on you. You have to decide as administrator which one you want to use, RIP or Ospf or EIGRP, and because they're metrics, okay. And this only comes in terms of best path when you have multiple. If you consider the previous one, there's no path, there's no other path. So this doesn't come into the consideration at all, depending on how complex your topology. When you have a topology, because you are the one going to design the network, right? When you have a topology, when it starts to get like this, you want to provide redundancy or simply, you want to have alternate path, then your router need to make choices during forwarding, because both match, right? Both reach this PC2. So both will match. So it's ambiguous to the router. Router needs to know which one to select. So it depends on you which protocol you want to use So the router, based on the protocol, will decide to compare hop count, cumulative bandwidth, or this. Okay. At the end of the day, it's up to you again as the administrator, right? But in general, this one is quite a good protocol because we have multiple costs that we can look at, right? We can look at to provide them some our metrics. So that's why on we also focus on the we'll focus a little bit on the EIGRP. Okay.
So different router have different protocol. Is that possible?
Sorry?
Different router has different protocol. Or
I think all the routers support this, or if I'm not mistaken, it's up to you which one you want to configure the router to use. I think Cisco has this RIP or Ospf and EIGRP. Yeah. And it depends on the model also lah, which one. But I think Cisco router has support for all three. Right? Of course, sometimes if you buy a router, maybe it just support this or just support that, then you have no choice, right? But if the router is the more expensive one, you have more options. I think you can enable whichever routing protocol that you would like to use. Yeah.
Okay.
Is that okay, Noel?
Okay.
Right. Right. So R1 to, yeah, if hop count R1 to R3 is considered as the best path by R1. Okay, because the metric is hop count. Okay. All right. So from now until several slides, okay, we are looking at the decision making in terms of best path, right? So depending on protocol, remember when you see the protocol being asked of you, then you know what kind of metrics is considered using that protocol. So RIP, hop count, right? Hop count. So in this scenario, it says that all routers have been configured with RIP. Okay, routing, here you go. This one, routing information protocol, which is hop count, metrics, hop count, right? There are two paths to reach 192.168.2. .2 network is here. Okay. R1 choose the path with lowest metric, right? Lowest metric, which means which one is the lowest metric, here or here? Path which one? Of course, if hop count will be this. Okay. Hop is like jumping, so I imagine it's easier to imagine this way, one hop. Whereas this going via R2 is one hop, two hop. So in terms of hop count, the lower hop count, the better. The first path, only one hop count is the preferred path. Right? Is it okay so far?
Okay.
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 Okay. So you can see in your routing table, okay? So it says here 192.168.2.0, 121 via 192.168.4.2, right? Here via serial, right? One hop count. So the other alternative is yes, 1, 2. This one is 5, huh? We can't see any 5 here. Is it 5? All right, so it's only this one. This size 5 or here 2, right? Remote 120. We are 32, and then another one we are 192.168.4.4.2 here, right? Okay, so 5 can be reached via this and via this, right? Via 101 and 00. But I don't see. Is this complete? Let me just check the next one. Oh yes, not complete. Yeah. So you can see here, it's not complete. It's different. This one is to reach 5. Okay, there are 2 alternate. This interface and this interface, or this via this and this to reach the 5. Yeah. So here we can see here is actually provided here, right? 192.168 has 2.0. Okay, 2 hops, because here we disable, right? So when we disable this one activated to be the path. This one given as the path. Here, when this is active, this one is ignored, and this one is the one that is chosen as the path. So it is part of the routing table, right? So let me just erase. So this one is an entry entered into the routing table, so that all traffic going to this network goes through path 1. Once you disable path 1, okay, this entry is entered in instead, because the other one not available already is removed from the routing table. So you can see for this one,
So
yeah,
can enable cursor. Can enable the cursor.
Cursor. Sorry, I was using the what do you call this? The pen. Yeah, using the pen.
Oh.
And you cannot see the pen, right? But just the ink, right? So I was pointing to that, okay. So when you disable this part, yeah, then this entry is deleted or removed from the routing table by the router, and this becomes active. So the entry is put into the router. Okay, but we can see the hop count by looking at that. Here the hop count is given there 1 because this one is active. This one is 2 because this one is active, and this is 2 hop counts, right? You can see R1 S001 is shut down. Okay, when you bring it down, right? Here, the both paths active. Router select this to put inside routing table. You shut down the path 1, it will be the entry will be replaced with this, right? If you switch on the or bring up S001 again, this will replace that entry again. Okay, because you want hop count, because you're using RIP, right? Okay, so only one path to reach. Okay, there is no load balancing here. Load balancing means both paths can be used and they share the bandwidth, right? Here with RIP, with hop count, They're not sharing. It's either one or the other. And if you're based on hop count, the one with the better hop count will be entered as the entry to be chosen by the router. All right. So that's hop count. Let's look at the next one is Ospf. All right. So in this scenario, the router is configured with Ospf to enable Ospf instead of RIP. Again, there are two paths to reach 192. R1 choose the path with the lowest metric. The metric, if you recall, is the bandwidth, total band accumulated or total bandwidth, right? I'm not mistaken lah, right? And it's given as a cost, right? As a cost. Okay. All right. So right, VR32. Okay, here we want the lower cost lah, right? Total bandwidth, total cost is means this cost is 64, and this cost is 64. Although it's 2 hops, but 64 cost means it's faster via here, right? So here the cost is 200. So this one will be more expensive than this. Is 128 and combined. Whereas here 200. So this will win, yeah. So this path, okay, path 2, okay, +1 again here. Sorry about that. And there's a cost 1 here, right? So 64 plus 64, 128 plus 1, it's 129 cost here. Right? So this path will win. So this path will be entered here. And you can see it's Ospf. R just now was RIP. Later we'll see if EIGRP is D. Right? So, and you can see that is the matrix 129 there. Okay.
So the metric 200 is not listed.
Just replace the hop count with the cost. Okay. And low cost means better bandwidth lah.
Oh, so the one the path 1 is not listed.
Sorry?
The path 1, the one the with cost 200.
Yeah, 200.
Is
mean bandwidth is lower lah. Compare. Okay. Recall the. Let me just bring you back to here. Yeah. Cisco's cost-based cumulative bandwidth. So that means whatever the bandwidth is already given a cost, right? Okay. So that means here will be lower cost compared to this one lah. This one higher cost because it's lower cost in terms. Usually when we talk about cost, the higher the cost is, the worse it is, right? The lower the cost, the better, right? So that's why the definition is using is cost, right? So we want lower cost. So higher bandwidth means lower cost, lower penalty lah. Okay, in terms of transferring the data. All right. Okay, so let's say we shut down this path because we want to see what happened. Well, then there's no more comparison because we only have one path. So definitely the one with the 201, okay, remember 1 is this part. So 200 and plus 1 is 201. Therefore, we know this path now becomes the entry in the routing table, right? So that means when it trying to match this network, let's say this is the destination host. So this is the destination network. When you try to match, it will match this path. Okay, before it matched this path. Okay, both available. Okay, the router choose which path to enable inside its routing table. Based on cost, then this wins. So this path is entered into the routing table. Okay, and here when we disable here, there's no more of this option. Cannot forward here anymore. So automatically there's only one left. So this one take over. It means the router will configure this path, right, as the path to forward to this network. Okay.
So the number 110/201. The 110 means what?
I have to find out this one. I forgot already what this one is. Okay. 110. Okay, we have to find out first. I think the information in the NetCat is more detailed. Right, more detailed. I have to find out this one. I forgot already what's that. Okay, is that all right? We find out later lah. You
okay.
Maybe you can help find out. Okay, from our NetCat notes. All right. Okay, so in this case, it's both enable, right? And then here we change the cost to 64. Possibly we, if you want that to automatically provide this cost, you use a faster cable or use a faster port, for example, right? Or you set the faster bandwidth for the serial cable, right? You can configure here the interface, right? So now it's 64, it's only 65. So even though this one is enable, this one is higher cost, this one is lower cost. So definitely this will win also. Okay, as you can see there. All right. So and if you're wondering why we're not doing any EIGRP, right, we're going to do that later in more detail, right? So here we want to talk first about load balancing, right? So load balancing means the router does not choose one based on the cost and then or what is the metric and then ignore the other one, right? The two, there's no RIP or Ospf, okay, is working on the assumption that after making the choice, that path is the winning path is the only path that it's going to use, right? It's not considering the other path. And since the effective way is to just provide that winning path in the routing table, because the router use the routing table to decide how to route. Okay, if the route is not in the routing table, even if it's available, then those particular packets cannot use the alternate path, simply because it's not part of the consideration, because it's not part of the routing table. So RIP and Ospf, as you can see, choose one winner and put in the routing table. But there's such a situation where we want to be able to use both, right? If we use both, that means part of the part traffic goes via one path, part of the traffic goes via the other path. And it means this is what we call load balancing. So you can see here, if a router has two or more paths with identical metrics to the same destination network, the router will forward the packets using both paths equally. So this is called equal cost load balancing, right? If you're wondering whether what happens if they're not identical, well, excuse me, the EIGRP supports unequal cost load balancing, meaning to say it doesn't need to be identical metrics, right? So the routing table contains a single destination network how it's configured in the routing table, but it has multiple exit interface. One for each equal cost path. This is referred to as equal cost load balancing. If configured correctly, of course, if you have alternate path, the traffic will be shared. So your network become more efficient. Okay, less laggy. Imagine going to campus, only one road. And this road from maybe Penampang area go to Musra, only one road. So that one road will be congested. If you open up another road, alternate road, then you will see perhaps traffic will be half, right? If equal cost, means half of traffic goes to using this other road, half of traffic goes to use the other road, and you can see that the flow of the traffic better, right? So jam will not be too bad. So in the case of our network, means congestion will be reduced because you're using equally both sides. Okay, but for equal cost load balancing simply means in order for it to work, means both paths must be balanced, must be equal metrics. But as you can see, the third protocol, EIGRP, can be configured to use unequal cost load balancing. So even they are not equal, you can still, it will still support to use those paths, right? So you can imagine if you have two paths is divided into two. Okay, you got the load. If you have three paths, then the load shared between the three paths. So it's a way to make your network not only redundant, have redundancy, but also have a more efficient network because you have multiple paths between networks. All right. You can see here 1, 2, 3 paths. Right. So just now, Noel asked about, which one should you use, right? So I mentioned that sometimes depending on the router, one router, perhaps more, a cheaper router will have one type of protocol. But more expensive one, then they might have all three different protocols. And it's up to you to choose which one, right? Right. So if a router, you can see, if a router has multiple routing protocols configured and static routes, static routes means you entered yourself, right? It is possible that the routing table may have more than one route source for the same destination network, right? Each routing protocol might prefer different path to reach the same destination. How does the router know which path to choose, right? So it's a situation where you have more than one protocol. And if you enable all protocols, what happens? So for Cisco, okay, they have this thing called administrative distance, or AD, right? And this allow the router to decide which route should be placed inside the routing table, right? So AD stands for trustworthiness. Although it says acronym for administrative distance, it says administrative distance means here administrative means it's up to the administrator. So this is configured by or determined by the administrator himself, right? So if the administrator is the one that's choosing the administrative distance to place, then you will understand what it means by trustworthiness. Means to say the administrator chose the path, because the administrator usually know the paths, the different path better. So if the administrator choose which path, then they can set the AD to bias which path will be selected, right? So in terms of this, it's called trustworthiness, okay? And what value to configure, right? So if you are the administrator, the lower the AD, the more trustworthy, the more it will be, the more chances it will be, or not chances, it will be the lowest AD will be selected, right? So you can see here, the administrative distance is given as values here, right? So connected and static is the most preferred one. 0, 1. 0 being the lowest, directly connected. No need to choose already. It's directly connected. You know straight away forward to this interface. So 0. No need to consider others, right? The next one, okay, remember the lower is the more trustworthy. That means the lower means it will be chosen over the higher ones, higher AD. So static is the next one, right? This is static, is that address is configured by the admin himself or herself, right? So should be considered prioritized. So just one high losing by one administrative distance to connected. Then the next is EIGRP summary route. Then external BGP. Okay, so BGP I think will be covered in the later chapter, so I'm not going to talk about it here. But EIGRP is the third protocol. Remember that we specify as options. The first one being RIP, and then Ospf, and then EIGRP. So you can see here EIGRP just above static, meaning we prefer EIGRP. And then internal EIGRP, IGRP, Ospf up here 110, and then we have ISIS. These are all other protocols, but we considered RIP or Ospf so far, right? So RIP is the highest AD, means between RIP and Ospf, you will trust Ospf more, so you will tend to use Ospf decision. Right, between Ospf and EIGRP summary route, you can see that we trust EIGRP more, then we will select EIGRP. But they all lose to connected or static. Means if you have EIGRP configured, but you go and put in your own entry, that will override what is the EIGRP values. Okay, because of the AD. So your configuration have higher priority being used in the routing table compared to EIGRP. EIGRP beats Ospf, Ospf beats RIP. Okay, so this is how it works lah. If let's say you have confusion because, well, the router has confusion because all routers protocol are enabled. Okay, so which one will win? Right? So by default, this is the AD. Again, you can override by providing your own AD, but these are the default. Yeah. So far, okay.
Okay.
Okay. All right. So this basically answered, I think Noel's question earlier on. Is it Noel?
Yeah, I see the 110 already.
Yeah. Okay. Right. So the next slide is basically an example, right? So we have Ospf and RIP both configured in all routers. So that what it means is that router 11, 22, and 3 here are all configured with RIP and Ospf. So which one will be selected? Since RIP is 120, Ospf is 110. If we didn't change the default, okay, that means Ospf will be more trustworthy. So router will ignore RIP and go for Ospf. So RIP means this one will be entered into routing table. This path R11 direct to R23 because it's one hop. Okay, RIP prefers lower hop count, so it will not consider this path because 2 hops. But Ospf, right, considers the cumulative cost, where 64 plus 64, 128 plus 1 is 129, whereas here is 400. So Ospf will choose this path, even though it's additional hop count. But based on this, if we are using, we're using iOS, there's an AD. AD is mentioned that by default, Ospf has lower AD compared to RIP. So Ospf will win. So Ospf will win in here against RIP. So the final path will be based on Ospf. All right. So just now, Noel asked me what is 110.
Yeah.
Noel? Yeah? Do you know what's 110 now?
It's Ospf AD.
Yeah. Yes. Ospf AD. Okay. Right. RIP is 120. Therefore, it loses out to Ospf.
The 129 is what? Is it the max? No, is it the highest number?
129. I think the highest number is this one, right? Based on this list. Wait, what do you get 129 from?
I'll do the one next. One next.
Oh, no, 129 is the cost.
Oh, the cost.
Total cost.
64
plus 64 plus 1. 129.
Oh, no,
Yeah.
okay.
So the right-hand part is the cost. If RIP wins, this one will be 1, because one hop. And 120/1. But since we have AD here, Ospf and versus RIP, Ospf has lower 110. It beats the 120 of RIP. Therefore, the routing table will have the Ospf path selected. It wins. No, that means its entry will be in the routing table. All right. Then if you have EIGRP or Ospf, that means EIGRP will win, right? Okay. Whether it's internal or summary route. Later, when we are learning about the administrative, when we have like a group of routers belonging to your organization, which area not belong to you, or you divide your network is so big that you can divide, then we'll look at this BGP and external EIGRP. Okay, for now we just look at this first. Okay. The routing protocol between routers. All right. So okay, so this one okay, not guys?
Yeah.
Okay.
So, all right. So further on AD information. A route entry for specific network, prefix and prefix length can only appear once in the routing table, right? So, but possible that routing table learns about the same network just because you have multiple protocol, right? But except for very specific, we should only use one dynamic routing protocol, right? That means, yeah, you have capability to enable all, right? But here it advises you should only use one. Okay, RIP, Ospf, and EIGRP are all dynamic routing protocol. Okay, just because the router support and maybe you can switch on all three, enable all three, you should only use one, right? In any case, I can't imagine unless you have mixture of routers routers that maybe you still want to use the old router only support RIP, then that's why maybe you want to enable RIP, right? If not, I don't, because if you have more processors inside your router, another thing I also think about is that there are more processing done, right? That means it takes more of your router processing capability, the router CPU, isn't it? You try to minimize the workload, okay, of your router. Okay. All right. So how does router know which source to use or to install? Yeah, this one. The AD breaks the deadlock if you use multiple routing protocol. So the AD is the one that is going to break the tie, right? Again, this one was given to us earlier on, right? Various routing protocols and the ADs, and these are the default values. So again, default value simply means you can, as administrator, you can change it. You can change. You can bias, right? Let's say you still want to use RIP and Ospf, but now you said I want RIP to win, then you can change the default value. But you must know why you want RIP to win. Because RIP, I think, is an older protocol. That's why it's considered as, it's only considered hop count, because I think previously the speed is almost the same. There's not much difference in the speed. What we have right now, we have gigabit, we have fast Ethernet, we have all this, right? So then the potential that you use cumulative costs for the bandwidth. But last time, the latency, because the maybe the route speed is the same, we're thinking about the router efficiency. So more hops mean more processing means slower. Okay, I think that was how the RIP was created during its time. So, but there are some legacy router that still use RIP. That's why it's still not. We don't force people. As you notice, just like IP version 4, we don't force people to get rid of IP version 4. We want people to slowly transition to the latest protocol. So RIP is still there. So that means its default means you can change, but usually we take the default value, right? In terms of preference, if you have multiple protocol. All right, so the next section is EIGRP. This is the second part, right? I'm going to stop here. We're going to continue this tomorrow, right? Because EIGRP itself, we are focusing on it more compared to RIP and Ospf, and there's a lot of info. Yeah. Okay. So half of the number of slides is dedicated to this EIGRP, including the configuration. So we'll follow this up later. Right now, we stop here first, right? Okay, and I'll stop recording. Now, I already shared with you guys the tutorial for EIGRP. So, sorry, not EIGRP only. So try to answer the questions that only covered today, right? And then the remaining questions that is focusing on EIGRP, since we haven't covered, don't have to do that one. But before that, you can go for a quick break, maybe 10 minutes. Right, and I'll see you guys in our tutorial meet.
Okay.
Is that okay?
Okay. Okay.
All right. Farah, I think you're on the right path just now. You're
The answer just now.
Yeah, I think you're on the right path. You mentioned ending, right?
Yeah.
Yeah, you're on the right path already.
Oh, okay. I think I type again.
Okay. So, well, your answer for number 1 is incomplete, yeah? You put in the purpose. Please add the functions.
Oh, okay.
And Calvin, you try again. This routing protocol, routing protocol. That's what we want. What's the purpose of a routing protocol? The answer for A is wrong because ARP is basically for layer 2 in the LAN involving switches, right? Involving switches, and it's a protocol to get the MAC address, right? If you have the IP address, you don't have the MAC address, then you use ARP, the protocol to get the MAC address rather than But this routing protocol works on layer 3, yeah. I mean, it's for what? Okay.
But it's just the rules only to let the to decide which route to choose. But I don't see anything any of this describing.
This is routing protocol. Routing protocol, not what. Here it says the question 1. What is the purpose of routing? It means the purpose of router lah. Here is routing protocol. So what's the example of routing protocol is RIP, Ospf, and EIGRP. What's the purpose?
Yeah, those are just rules. Rules, and then they use them to choose which path to prefer.
So think about what we mentioned earlier on. There are 2 ways to update the routing table. One is static, one is dynamic. Right? Static is administrator will update the routing table. Dynamic, how does the dynamic updating of the routing table work?
They just use it. Isn't it isn't it A? Just use they use they just figure it out themselves, but isn't it?
Yeah, how do they figure it out themselves?
Yeah. Need to share information. To share information.
Yes, correct. Yep.
Oh, I thought it's another thing that allows them to share information, not the protocol to let them.
Yes, the routing protocol is job is that also. That means they will remember the directly connected network. Each individual router know how to populate its routing table using directly connected network, but it doesn't know about remote networks. So the routers need to speak to each other, right, in order to share their own directly connected networks. Okay.
Is it really the protocol doing the communicating?
Yes.
Oh, I just
protocol simply allow routers to understand each other. If they're not using protocol, they don't know how to communicate. That means protocol is a way to standardize communication. So that when they give each other information, they follow particular protocol, so that they know what to expect, what each router sending information mean.
So like translator like that.
Yeah.
Oh, okay, I understand.
Yeah. All right, Farah. Okay, so it's not part of the answer, but I tell you what happened next. Why it needs to know whether it's on a remote network. So the PC, when it detects that the network address for the destination is not in its own network, it is a remote network. That's how the PC know to send the packet to gateway. Yeah, Farah?
Okay.
Yeah. After this part that you explain, right? Then the PC, then it knows lah, the destination is a remote network, right? So instead of sending it to the, within its network, it knows it's remote. So it will send to the gateway address for the router to forward it, right? Because it belongs, means the destination is remote network, the router is the one's going to forward it. So which means it knows, the PC knows that, remember, inside the LAN is working on layer 2 MAC address. So basically PC1 is going to send it to the gateway address. Okay, switch know which one is the gateway address because it knows that particular gateway address IP is actually using MAC address, right? Using MAC address. The MAC address, that means within the LAN, how the PC sends that packet to the router, of course, is using the MAC address of the gateway address. Okay, so that's how it cooperates on layer 3 and layer 2, right? Basically, what I'm saying is, after it knows, the PC1 knows it's on a remote network, it forwards the packet to the gateway address. The gateway address is basically the interface for that LAN connected to the router. Okay.
Oh, I see.
All right, so for Novel, it's true because PC1 and PC2 belongs in the same network, so there is no need to involve the router. Okay, when your two hosts are sending each other and they both belong to the same network, only the switch is required. Okay, and work with MAC address for the switch. Okay, so this is opposite of Farah's situation. Farah's situation is remote network, so it sends to the router being the gateway, right? So the part B, okay, since PC1 and PC2, you can see that they are both belonging to the same network. There is no need to involve the router. The switch is capable to forward between two hosts in the same LAN or same network, right? These two lah. Okay, I'm just going to, yeah, these two lah. The PC1 and PC2, the same network. This is same network. So that's why it's true. Right, so let's look at Kelvin's for C. When PC1 sends a packet to PC3, PC1 is here, PC3 is right on this other side. The packet is forwarded to the default gateway, which is this one. This router 1 is the default gateway for PC1 and PC2. So if PC1 wants to send to PC3, the packet from PC1 is forwarded to the default gateway, which is R1, because the host device cannot communicate, this one, yeah, with devices outside of the local area network. Correct? True or false? So
I think
Kelvin,
it's like right false because isn't it the default gateway just if they got no choice they just go one way on the default?
yeah, the question say the packet will be sent to gateway. Is that true or false? If PC1 want to talk
But
to PC3.
it may also go to PC2 though, I think.
But PC1 is sending to PC3 or?
Yeah, but it's sending this, yeah. I think, okay,
Yeah.
but just the reasoning, I think, not right. Can.
So why is it false? If
Ah.
PC1 wants to send to PC3, so it's PC2 is not involved. If PC1 sends to PC2 directly, you can see the path PC1 switch PC2, no need to go R1. But PC1 to PC3 have to go to like this, right? The path is PC1 switch router PC3.
Do you assume that there's other networks in the middle?
Well, this is the
entire network.
Yeah, this is the network that we have under consideration.
Yeah, just default gateway. Since there's only one path to go, they just send it one that way to PC3 only.
Yes.
Don't think there's anything about cannot communicate device outside local network.
Yes, without the gateway, PC1 and PC3 cannot communicate because PC3 belongs to a different network. That's what it means.
Oh.
Okay, without if we don't send to gateway, can PC1 communicate with PC3?
Oh, cannot.
Right. So here, the statement say when PC1 sends a packet to PC3, so sending a packet, the packet is forwarded to the default gateway, right? Because the host device, which is PC1 or PC2 or host device within different networks with the sender and destination different network cannot communicate, see, if they are not in the same network, because true or false.
Oh, so that's what the statement say. Okay.
Yes. So it should be true. Yeah, correct. Should be true.
I just don't understand the question, I guess.
Yeah. Be careful, Be careful. And not only to Kelvin, to Noel and Farrell. So
okay.
Please, read through the question. Sometimes just because we misunderstood, if you're not sure, I'm pretty sure you can ask what the question means, right? If you're not sure what the question means, feel free to ask. If your question is not appropriate, the examiner will let you know. I can't answer that. If it's appropriate, it's within the what? If you're not sure, you can ask. Try to ask what it means. Okay. In most general cases, the question should be clear. But if you're having confusion about the question, there's no harm to ask what it means, what the question means. Okay. Is that okay, Kelvin?
Okay.
Right, so D, the default gateway is the device that routes traffic from the remote network to devices on the local network. True or false? Okay, so the opposite way is it? The default gateway, which in this one is the device that routes traffic from the remote network to devices on the local networks. Okay, so usually, Farah, when we describe default gateway, okay, we normally explain the other way. Okay, routes traffic from local to remote network. Okay, but here the statement is routes traffic from remote network to device on local networks. So strictly saying, default gateway is not the only device that routes the traffic from remote networks. Right? So in order to route traffic from remote network devices, it goes through, depending on the topology, it goes through other router as well, not only the default gateway. right? Okay, fair.
Yes. So
So
it should be false because it's not in a.
yes,
Oh.
it should be false because if you take the statement at its face value, it's just saying that's only default gateway. So cannot be the default gateway. There are situations when, yes, if the remote network directly connected to your default gateway, then yes. But in this case, in our consideration here, your multiple routers from remote to local network. So cannot be only default gateway. Other routers also involved. So false. Okay.
So it depends on the topology first
Yes.
lah. Okay, okay.
Yes. Yes. All right, so number E, fill in the information for R1. Assume that network is already converged and routing protocol used is RIP. Okay, so RIP basically focus on how many hops, right? How many hops away. Okay, so let's see. Network 192.168.10. Okay, we are considering R1, yeah? R1 is here. So 192.168.10 is this one on the left, right? Okay, so hops, 0 hops, correct, because it's directly connected already. So next hop IP is you should mention there, Noel, you cannot put dash. You should put directly connected. All right, and the exit interface for the router 1 to go to network 192.168.10 is, okay, this is router 1. 192.168.10.0 is this network. So the interface attached to this network is this interface, right?
Oh, yeah.
Yeah. So it's G00, correct?
Sorry,
Right.
the
Next
hop IP
it's
is on the
directly connected. Next hop IP is directly connected.
Oh,
Not there. The other part. Next hop IP, yeah. Yeah. So it's directly connected to that network. Right. So 11 is on its right hand side. So it's G01 in exit interface, correct? And then it is also directly connected, correct? R1 here, this is dot 11 here. So it's directly connected to R1. Okay, the dot 11 network. Okay, so now we consider dot 12. Dot 12 is remote to R1. Next hop IP, next hop is R2, right? R2, next hop IP is R2, and R2 G01 is dot 7, right? You can see dot 7 there. The the next hop IP, next hop is R2. R2, next hop IP, the IP we consider is this one, right? Attached to R2, which is dot 7. So it's 192.168.11.7.
like this.
I don't need to put R2 already because there's only the one that's a unique. And it's G01, correct. The next one is dot 13, which is this network at the right hand side, right? So the next the next hop IP is for R3.9, right? 12.9. Is it dot? No, sorry, not dot 9, because it's remote, so you don't know. So the next hop IP for that 13 is this one also, to go through this dot 7 R2. because we cannot see that one. The R1 cannot see that one, right? It's over there. So still using 11.7. That means this interface on R2 allows you to go to that R3. Okay, which is which goes to 192.168.13. So the hops correct lah, 0012. Okay, 2 hops away to this network. 1 hop away to this network, directly connected to this and this. All right. So okay. So now it's all correct.
Okay.
Sir.
Yeah.
I'm not sure how the hop works.
Oh.
I don't know how it works.
Okay. Your okay. So hops means how many hops away. So you think about is jumping. So if you're considering the router R3, okay, means here lah, right? This router here R3. So then how many hops away means how many router away. Okay, hop is another name for router, away from the network you consider. So let's say the 10 and 11. 10 is all the way here. In order to reach 10 means from R3, how many routers? 1, 2. So this network is 2 hops away.
Oh, it doesn't count from R3?
No, it counts, you start from R3, but you count from the next router. So R3 to R2 is 1 hop, because we count the hop, the jump. Hop is another word for jump. I think that's why they use hop.
Okay.
R3 to R2, you jump to R2, one jump, 1 hop. Then R2 to R1, another one. So 1, 2, 2 hops. Okay.
Okay.
So how many hops to 11?
To 11, 1.
Yeah, correct. So how many hops if directly connected to you?
0.
0. Means no hop, no router. Okay, no router needed. So
so this one is just a reverse from Noel's answer.
Yes, because you're considering from R3. Noel's point of view is from R1. Consider. Yeah.
Okay.
Yeah. So let me just correct that. So let's look at Kelvin's number F. Fill in the information for R2. So we're considering from R2. Assume network already converged and routing protocol is RIP. So from router 2 to 11, directly connected, correct? Directly connected, correct? And then 12 and 11 is directly connected. And 10 is, 13 now, 12, 13. I think this one is.
This one only need 3. Oh.
How come yours is 11, 12, 13, 13?
Oh, is it wrong?
Yeah, you should. It's 10, 11, 12, 13. We consider all. Yeah.
I thought router 2.
Because there are still 4 networks over there. So from R2 to network 10, right? 192.168.10. How many hops from R2?
Oh, from R2 to the 10 is, I think, 2 hop.
R2 here. This one is here. So one hop and you reach it.
Or the route, only the counter router hop, not the,
Yeah, just count the next hop to you, like from here, one. Okay.
oh,
So not directly connected anymore. So it's this one lah. 192.168.11.6. This interface on R1. Okay, to go to this, then you have to go through this R1 interface 192.168.11.6, and then yeah, go ahead and do first. I'll check. For Fairer, yes, 12, because considering R3, 12 and 13 is directly connected. Yes. So what is the exit? Okay, you do next hop IP. So 10 means from R3, right? From R3 to go to 10, you have to go through R2, 192.168. .12, and then you can see the .8. You can see this one is .8. So exit interface on R3 to go there is what? What is the interface? Interface name?
Is it the S?
Yes, the zero port, interface there, S0/0/0.
The word so small, I thought it was G.
It's S, serial. You can know if remember the standard we use for cable. If the cable is like a like lightning, like this, we red color lightning, that one is serial cable.
Yes.
So if serial cable usually use serial interface. All right, so the next one is 192.168.11 here, same thing, just to go to here as well. Yeah, and the exit interface is also the same. Right, still need to go through here. So the exit interface on R3 is still serial 000. Okay. Now, when you look at 12, directly connected to this exit interface, still the same, right? Farah? Still this one, right?
Yeah, it's still the same.
Yeah, correct.
So it's for the 13 also the same.
13 is this side.
Oh, okay.
This side, right? So
Yeah.
interface to go to this, exit interface to go to this side
is the G.
Yeah, G00. Correct.
Oh, okay. Understand.
So let's see here, Kelvin.
I don't know the next hop IP.
Okay, so you at R2 to 10, next hop IP is this next hop IP. So 192.168.11 dot this one.
What?
Yeah, .6.
.6. Why 6?
Because that's the next hop IP. This is next hop, right? The next hop IP that you are facing, you're looking at.
The number there. The number.
The number is .6 there.
Oh.
Right? And exit interface, yeah, correct. G01 this side. Anything to go to the side is exit is G01. Right, so 11 is directly connected, 0 hops, G01, correct? And then this side to 12 is directly connected, 0 port S000. The next hop interface is direct. Okay, so 13 is next hop interface is .9, correct? .9 and exit. Okay.
Oh, this.
Correct already. I think all understand already how to look at and this. What is the importance here? Not only because you need to know how to answer a question. Later, when you are doing packet tracer, right? Then you know already lah. So when the question is talking about the next hop IP or what, then you know which interface the packet tracer explanation is referring to. Okay, all right. So the lesson you learn here can be useful for you when you're configuring or when you're working on packet tracer also, right? So sometimes the packet tracer, maybe the statement, whatever they're asking you to do, they just say, all right, so next hop IP from R1 is this, then you guys know lah which one, how to read the topology. Okay. Right. Here, let's correct it first. Directly connected. And so this one. Yeah. I think just okay. Right. Okay. So I go back to question number 1. I refer back to functions to determine the best path. Okay. Based on the table. That's correct. All packets towards destination. Correct. So best path is selected by routing protocol based on, I'm looking at number 4 now. Based on the value or metric it uses to determine distance to reach a network. Okay, so the metric, yeah, explanation of the metric. Is a term used to measure, I think, just correct your grammar. Metric is a term used to measure the distance to a given network. Usually, a network with the lowest metric is selected to forward a packet, therefore is known as the best path. All right. Okay, right. Okay, so Kelvin, can you also mention the type of protocol, the name of the protocol? Let's say you say hop count is used by. Give the full name. Yeah, give the full name. All right.
Then they only ask for metric, not the protocol.
3 examples of metrics. Yeah, they give you give hop count but it's just put it. It's okay.
Oh.
Yeah, it's good for you. I always tell this to my students. There's no such thing as too much info. Only thing you need to measure the time available for you in order to give you answer. But if you have time, give as much as you can within the time allowed, right? Because you put yourself in a position where you give the marker more chances to give you marks, because the marker can only mark what is there, right? What is there written by you or submit that, right? So if, of course, you have to balance between remaining time or available time for you to provide answer, and look at the marks also lah. The marks will guide you how much you need to write in. But always remember that the marker can only provide marks what is available, right? So as long as not out of topic, providing the routing information together with the answer is no harm in it. We don't cut marks if you give more answer, right? We might ignore, or if happen to be that we also require you, right, to give, then there's no loss on your part lah. All right, but of course I know have to balance the time available with amount of information or answer you give. In any case, in here, good for you also lah, right? When you do revision, you can see straight away hop count, RIP. Okay. Number 5, when a router learns that multiple paths are available to a destination network from the same routing protocol, which factor is considered by a router to choose the best path to forward a packet? All right, so yeah, the path with the lowest metric, correct? Okay, well done. This one is exactly right, because we, no matter what whatever, they're not actually saying what metric is it or what protocol, what metrics, right? So in this case, we straight away know whatever metric it is, usually is the lowest cost metric. So we always choose the lowest metric. That's the standard by the protocol. Okay? They always try to, if it's hop cost, lowest cost. If it's hop count, lowest hop count. Thing like that. That's the way they do it. Right? Okay, the rest, remember, Kelvin and Noel? Okay.
Okay.
It's usually always lowest metric, no matter what metric. Okay, whether cost ka, hop count ka, is usually choosing the lower value. Right. So when a router learns that multiple paths are available to a destination network from the different routing protocol, which factor is considered by a router to choose the best path to forward a packet? A router consider the value of different routing protocols. Correct. So then you have to choose AD, right? All right. So in terms of the value of the AD, lower AD. Okay. So all the keywords are here. So you mentioned administrative distance. You mentioned that what will be selected will be the lower AD value, right? And yeah, it's considered to be trustworthy. So that's the right selected one lah. Correct.
I should put this one also, the routing information.
Okay. It still got a lot. So okay, so I have to stop here, right? Because I have a meeting at 4:30. All right. So those I'm not sure about the rest. I think have we covered? Not yet, right? Have we covered? Answer the
I think it's
process.
EIGRP.
Okay. All right. So again, we will continue EIGRP tomorrow, and then we continue with the security after that. All right. Hopefully, you guys are so far okay. Can do. No problem. All right. So I'll see you guys tomorrow. I have a sorry to rush. I have a meeting at 4:30.
Okay, sir.
Okay,
It's okay.
All right.
Thank you, sir.
Kelvin, Farah, and
Yes, sir.
yeah, I said thank you, and don't forget to revise tonight for tomorrow test. I will invite
Okay, sir.
by tomorrow.
Okay.
Okay. Bye bye.
Okay, sir. Thank you.